So in organic chemistry, we're very interested in carbon. And it turns out that carbon can make almost an infinite number of structures when combined with atoms such as nitrogen, oxygen, and a few other elements. So because of that, the ability to describe a specific molecule you're interested in to another person turns out to be a very important skill to have. And in order to describe these specific molecules, you have to almost learn another language, which is in effect what we're about to try to do. I'm going to teach you to a certain degree how to speak the language of organic chemistry, and although this language is very complex, you'd be surprised just how much detail you can get across with a relatively small vocabulary. So just like with any other language, one of the first things that you do is learning how to count to 10. And specifically the things that we're counting are going to be the number of carbons that we're going to have in a specific molecule. And so now we can count all the way up to 10. And each of these numbers actually has a specific prefix that we use whenever we're talking about a molecule. And these prefixes are meth, eth, prop, bute, not but, bute, pent, hex, hept, oct, non, and dec. So this is the way that you would count from 1 to 10 when we're trying to describe 1 carbon, 3 carbons, 6 carbons, 10 carbons, and so on. So counting actually turns out to be a little bit more complicated when you're trying to describe carbon, because carbon can actually take on a variety of different forms. And these can come with the different hybridizations that we have for carbon. So this particular carbon-to-carbon bond, we can describe this carbon as sp3 hybridized, sp2 hybridized, and sp hybridized. And each one of these different hybridizations for each one of these carbons, here, here, and here, they have their own suffix that can go along with them. So if you were to talk about this molecule, its suffix, the way it ends, all of its naming conventions, is with an ane. This molecule ends with an ene, and this molecule ends with an ine. So if we were to describe this molecule with 1, 2 carbons, the way we would describe it would be both with the prefix and with one of these suffixes. And since we have an sp3 hybridized carbon here, we would count 1, 2, so eth, and since it's sp3 hybridized, it would end in ane. So this would be ethane. This carbon combination, because we have 2 carbons, would still be eth, but since we have an sp2 hybridized carbon, this would be ethene. And at this point, you're probably catching on to a trend. This carbon combination, again, 2 carbons, but now sp hybridized, so this would be ethyne. Other simple permutations could be, if we counted this carbon unit, we'd have 1, 2, 3, 4, which would be bute, and so we only have an sp3, and so therefore the suffix would be ane. So the way we would call this molecule would be butane, or butane. And now what happens whenever we have more complicated structures for this sp2 hybridized configuration? It turns out that for this molecule we have 1, 2, 3 carbons, but we have a little bit of a mixture between sp3 and sp2. If you have this kind of scenario, it turns out that sp2 has what's called a higher priority than sp3. And so if we were to name this molecule, we would utilize the ene suffix because it has a higher priority. And so this would still have an ene suffix, but we'd have 1, 2, 3, so this would be prop-ene, so this would be propene. And this molecule, in a very simple combination, if we had 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons, we'd have a pent. And since we have an sp hybridized carbon, this would have an ine suffix. So this would be meth, eth, prop, bute, pent, pent-ine, pentine. So what happens if we get away from just having carbon in our molecules? In organic chemistry, we definitely utilize carbon quite a bit, but other major players are going to be oxygen and nitrogen. Oxygen and nitrogen show up all the time. And so we can actually combine carbon, oxygen, and nitrogen in a variety of ways. And there are some ways that reappear over and over and over again, so we actually have names for these. This combination of carbon, oxygen, and carbon shows up so often that we give this guy its own shorthand name. And if you see this carbon, oxygen, carbon, where carbon is sp3 hybridized on both ends, this has a name. It's called an ether. Another carbon-oxygen combination is if you have only one carbon on one side and on the other you have a hydrogen. And in this case, we don't have an ether anymore. This is what's called an alcohol. Another carbon-oxygen combination would be if you had a carbon bound to two other oxygens. And in this particular way, if you had a carbon bound to a carbon, which is doubly bound to an oxygen, and you have another oxygen with a hydrogen, this type of combination shows up so often that it gets its own name as well. This is called a carboxylic acid. And then if we change this hydrogen to another carbon, it gets a whole new name. This is called an ester. And now if we move away from the carbon and oxygen combinations, we have a couple other very common combinations. And the first is if we have a carbon bound to a nitrogen, and if that nitrogen has two hydrogens attached to it. These combinations get their own name, and these are called amines. And if we just replace one of these hydrogens with another carbon that has another carbon with doubly bound oxygen to it, this gets its own name as well. This is called an amide. So all of these combinations of oxygen, nitrogen, and carbon, these are all called functional groups. And these functional groups are just very quick, easy ways to describe relatively complex structures. And all of these structures are very, very common. They show up all the time. And because they show up all the time, that's why we give them very common names. And there's actually one more carbon-oxygen combination I want to give, and then we're going to move on to trying to name more complex situations where we just have carbon. So the last functional group that I'd like you to know is this combination where you have a carbon to carbon to carbon, and this middle carbon has a double bond to an oxygen. This type of configuration is called a ketone, and these ketones show up all the time as well. And again, these functional groups can get relatively complex. These are probably one of the simplest forms of each of the functional groups. But again, you can have a lot of variety while still maintaining a carboxylic acid. You could have about 1 billion esters that you could potentially draw. Amines in nature are so prevalent, there's no way I could put them in the entire semester. But we'll talk about very easy examples about how to name amines and a couple other functional groups.